All right, so today's video is about composite functions or composition of functions. It simply means more than one function to forming a function. So for example, we have f of g of x. So that can be written as f parentheses g parentheses x. The domain of f of g of x is all the values of x in the domain of g such that g of x is in the domain of f. So all your g values will be values in your f function. Let's look at an example. Here we have a table that gives us our domain and range for the g function, the domain and range for your f function. And if we go from the domain all the way to the range for your f and g function, that will be f of g. So how do we go about doing that, finding f of g? Well, to find f of g of 1, you first find g of 1. So you look for g of 1, and that corresponds to 4. So you're going to use 4 as your input into f, sorry. So now that you use 4, that corresponds to 8. So g of 1 or fg of 1 written this way is 8. So you look for your g function and then you input that into your f function. So the order of function operation is the same as the order of operations of numbers and expressions. To find fg of 3, evaluate g of 3 first, then substitute the results into f. So g of 3 corresponds to 6, and then 6 corresponds to 12. Finally, if you need to find fg of 5, 5 corresponds to 8, and then 8 corresponds to 16. All right. Now, something to note, when we have this expression here, or it may be written like that, it is read as f of g of x, all right? F of g of x. Or if we have h k x, it will be h of k of x. Something to also note is that fgx is not equal to f of g of x. So this fgx is just f multiplied by g, but f of g of x is a composite function. Let's do an example. We have f of x being 2 raised to the power of x and g of x being 7 minus x. Find fg of 4. Well, we will input 4 into our g function. So we do g of 4. We are going to use our g function, which is 7 minus, and wherever x is, we are going to replace that with 4. 7 minus 4 gives us 3. Now, we are going to use this 3 and input it into our f function. So f of 3, that is 2 raised to the power of 3. And that gives us 8. All right. Another example. We have the same two functions, f and g, and we need to find g f of 4. So we take that 4 and we're going to place it into our f function. So our f function is 2x, or 2 raised to the power of x. So that will be 2 raised to the power of 4. 2 raised to the power of 4 is 16. Now that we have our f of 4, we are going to use our answer and put that into our g function. So now we have g of 16, and that will be 7 subtract x, which is 16. And our answer will be -9. It's that simple. Here we have another example. We have f of x is x squared minus 1, g of x is 1 minus x. We need to write the composite function of fg of x. So again, we are going to start with our g function. However, notice we do not have a number here, we have our x term. So we are going to take our g function and input that into our f function. So what is our f function? X squared minus 1. And wherever we see x, we are going to put our g function. So we are going to replace x with 1 minus x. And that should be squared. Subtract 1. We can expand that to get 1 minus 2x plus x squared. And don't forget that -1 here. I'm going to use a different color so that we can see the difference. So this is the -1. This is the -1, -1. And this x here is replaced by our g function. And this expanded gives us this. So now we can simplify and we are left, these two will cancel. We're left with -2x plus x squared. All right. One final example. We have f of x and g of x, and we want to write a composite function for g f of x. So we're going to take our f function and enter it into our g function. So we take this and enter it into our x position. So when we do not have a number and we're writing an expression for the composite function, we replace our first function with x in our second function. So x here, we're going to replace x squared minus 1 for x, and we have -1, subtract. Instead of x, we're going to put our f function, which is x squared minus 1. We can simplify that to get 1 subtract x squared plus 1, because that negative and that negative gives us positive. So we have x squared minus 1 over -x squared plus 2. And that's our answer. Something to note is that whenever we have a division, we do not need our denominator to be 0. So here for x, x would be any value other than positive or negative root 2. Because if we have positive or negative root 2 there, then our answer will be 0, and that will just make the expression undefined. All right, so try to remember that there. One point I would like to make is that if you look at your answer for fg of 4, which we got as 8, and you look at the answer for gf of 4, the same two functions, however, we switch the position, you notice that we get different answers. So fg of a number is not equal to gf of that number, even if we're using the same function. So that's something to note on the composite function. So that's it. See you in the next video.